Keep blowing, keep blowing, keep blowing, keep blowing, keep blowing.
So after half a bottle of red wine, I was found once again drunk whilst in charge of eBay, and this week's misguided purchase was an AVO multimeter, and for those playing along at home, it's a model number M2006. When buying a multimeter, you need to consider things like the accuracy and the precision, you need to consider what range it's got, and maybe things like what safety category it's got, depending on what voltages you're working at, whereas I made the decision based on that it was yellow. So this particular AVO meter is interesting that it's got this Network Rail railway symbol on here, and you can see it also says catalogue number 40/56003. Well, this particular meter is approved for use in railway signalling applications, because believe it or not, when you do turn up to do some work on the East Coast main line with one of those voltmeters that came free with a magazine, it is somewhat frowned upon, but this actual meter is approved for railway use. Don't assume because it's approved that it's a particularly good meter. The approval basically just means that they can charge any ridiculous price point that they want and you'll pay for it. Now, although this meter is badged up as AVO, my understanding is that these are actually a rebadged Gotham Metrawatt meter. So although this meter is somewhat old technology, it's oldie, but it's a goodie. And what's even better is that I didn't actually pay very much money for it, but unfortunately it did arrive bareback in that we haven't got any test leads for it, which of course meant that I had to go on Amazon and actually purchase some test leads for it. Now of course I did actually want to buy some Pomona test leads, but actually being just far too tight, that was never going to happen, was it? So basically I've just got Amazon's finest. So let's see what I bought. And the model number of these test leads is KET01, and they're made by, it looks like KAIWEETS, something like that, KAIWEETS. So these particular leads have got actually a 90-degree bend at one end of them, and of course this end goes on the actual multimeter. And whenever possible I do try to find meter leads that do have these 90-degree bend on, because otherwise they can actually stick out too far from the face of the meter, and that's a problem for two reasons. One, they can actually get in the way of you operating the selector switch, but the other problem is if your meter falls over or gets knocked, the extra leverage from the long test leads sticking out. In fact, let's push one on. You have a long test lead sticking out like that. If your meter was to get dropped or fall on that, it can break off the socket on the meter. So yeah, you'll find it's much better to use ones that have got a 90-degree bend on. Okay, yeah, they are definitely silicone wire, but they're not as soft and pliable as I perhaps would like. Now, one of the reasons that I actually chose these leads above all the others that are available from Amazon, and there is lots available on there, is because they had a variety of different probe tips that we could use on them. So I often work on things like valve radios. So when I'm working on a valve radio, I like to be able to clip one of my leads onto the chassis. So the fact these came with a little crocodile clip, which I can actually assemble onto here, that was actually a plus for me. So that's one of the probe styles. And then of course they come with the more conventional probe type here. So we can also install this into the back of here, and then we've got a conventional probe. And the pointy probes also come with a little sheath over them if you don't want so much probe tip exposed. So you can actually have the unshielded probe like that, but if you don't want to accidentally short things out, which can be a good idea, you can actually shroud the probe. And they do come with those little covers which will almost certainly lose immediately. So going back to our AVO meter, one of the nice features about this particular meter is I think it's probably got one of the fastest continuity beeps of any meter. It's actually as fast as you can possibly do it. And it is a latching type beep, so it doesn't matter if you only touch it very briefly, the beep lasts the same amount of time. So having played with these test probes for about half an hour, I've got to admit they do feel somewhat cheap in the manufacture. The best way I can put it is they feel a little bit plasticky. Now of course test probes are made out of plastic because they're a good insulator, but it does feel like a particular type of hard plastic. A lot of the better probes you can get, they're kind of over moulded with a soft rubber grip. I'm sure it doesn't make a lot of difference to using them, but they would just feel slightly nicer. They feel cheap. Now the other thing that I'm not liking, again it's difficult to explain, but you can see where the actual probes actually clip together here, they've got a little ridge, a little piece of plastic like a safety guard, and I guess you maybe use this with some different style of probe tips. Maybe it's a finger guard to stop your fingers sliding up the connector, but it just feels a little bit annoying. Now your hand doesn't naturally rub against it particularly, but you can kind of see that the probe's coming up against the back of my hand here, and just this ridge, I'm just finding it a little bit annoying. Maybe it would be fine for you, but I find it annoying, and overall they just feel a little bit cheap. So taking a closer look at the business end of the tip, they're not actually super fine. I'm guessing that they're probably manufactured out of something like stainless steel. Certainly they're not magnetic anyway, and they don't appear to be plated. They're certainly not gold plated or anything like that. And they're also not the most pointed tips I've seen. In fact, I've actually got to press really quite hard before it gets ouchy. Ouch. Ouch. Yes, but I have to press quite hard. These could be sharper. Now, the reason that sharp tips are important, because these are the actual part, these are the business end of the probe, if you like. These are what are going to make contact with your component legs or your circuit. And the problem is, of course, component legs and even copper tracks, they get thin layers of oxide on them. So the reason you want a sharp probe tip is you want something that will scratch through that surface layer of oxide, and it'll give you a true reading. Now, I don't think these would actually cause any problems, especially not in the type of circuits I work on, but yeah, they could actually be sharper. But there's certainly nothing wrong with the probe tips themselves. They're what I would call a general purpose tip. Now, of course, depending on what you're working on, you might need something more specialised. So for the old school type equipment, such as these dual inline packages that I tend to work on, these tips are actually absolutely fine. Actually got no problem. Can quite easily get them on each of the component legs without any danger of shorting them out. No problem. But these large tips are a little bit of a compromise, and for example, if you want to work on something smaller, like these surface mount devices, it's pretty much impossible to touch just one pin without touching the one that's adjacent to it. So again, if this is the type of thing that you're into, this is not the probe style for you. So for this type of work, you would certainly need a needle tip, and even this is a little bit too large for me to work with without a microscope. Well, if your usage case is something like mine, where you don't actually do an awful lot of surface mount work, the fact that these probes are actually a modular design, again, I think is an advantage, because of course what we can do is you can just take off this large and unwieldy probe, and we can just install this long reach needle tip, and yeah, so that really does extend the usefulness of these probes. Now, you'll have to buy this needle tip separately, but these tips are quite a lot cheaper to buy than just you know, a complete probe tip with a needle on like this. So I do find this style of probe, again, a good all-round solution. Now, I did mention earlier that I think it's quite an important feature for me that you can actually split these probes, and I'm going to put a crocodile clip on it, and the reason being is because I don't like to have two hands inside of a piece of equipment, because I work on high voltage equipment, and it's not very safe if you have two hands in that piece of equipment. Now, the reason for that is because if I'm actually probing inside a piece of high voltage equipment, quite often I would maybe be resting one hand on the chassis, because that's kind of a natural position to put it, or I'll be leaning against a piece of metalwork that's earthed, and then I'll be probing with the other one. But if this hand comes in contact with something that's live, what will happen is the voltage will run up my arm, it will run across my chest and through my heart, and then it'll run back down this arm into the grounded chassis. So for me, that's dangerous to use this type of probe for a lot of measurements. So what I always prefer to do is I always like to work one-handed in a piece of high voltage equipment. So what I will do is I'll clip onto the chassis, and then I will work one-handed, and even if my hand is in contact with back of my hand is in contact with a chassis, if I do brush against a live wire, the path of the electricity is only going to be into my hand here, and then maybe to earth through the chassis that I might be touching. So yeah, it's kind of a safety tip. I mean, you may not find that such a big deal, and especially if you work on low voltage equipment, digital electronics, things like that, that's probably not an issue at all. But for me, it's quite a big issue, so that's why I go for these probes which can be split. And talking about splitting them and putting crocodile clips on, these probes do also come with these mini grabbers, and again that's also quite useful as well, because you might want to keep to make a static measurement in a piece of equipment, and of course if you're actually trying to hold these onto an integrated circuit like this, that gets boring quite quickly. And because the mini grabber probes themselves are quite small, they don't actually short out against the adjacent contacts, because again if I go to the slightly larger crocodile clip, so I'm going to put one of them on, of course you run the risk of shorting out multiple leads. No. Yes. Let's try our mini grabbers on a circuit board. Certainly they don't have any problems on these larger through-hole components. And just doing a little bit of a tug test, they do actually feel very robust. I don't think the ends of these are going to break or fall off. And once you've got the clip around the component leg, it is really solidly held there. And certainly they do fit really securely onto these pin headers. But I would also say that these mini grabbers are relatively large, and again for fine work such as trying to get onto the legs of this IC here, yeah, they're just too big, they just won't go around it. And if surface mount is a particular bag you're into, well, you can forget it. Now of course it's possible to go out and buy much smaller mini grabbers than these, but in my experience the voltage range would be much more limited to low voltage stuff, and because the end of the probe tips would be smaller, it wouldn't fit some of the things that I like to work on, but for me that exactly suits my usage case. So the test leads are rated at 10 amps, and as you can no doubt see from the power supply here, I've actually got 10 amps flowing through them, and at 10 amps they seem to be dropping about 0.3 of a volt across them, and I would say that these test leads, they are actually heating up very slightly. I would say with 10 amps flowing through them they are just warm to the touch, but I don't think you'd want to put much more than 10 amps through them. Well, I guess while I've got the AVO meter on the bench, I might as well just go ahead and test the 10 amp range on it, and as you can see, 10.06. So we do seem to be in agreement. Well, you can see on the bench I've got some other probe tips. Now these didn't actually come with this test lead set, these are just other probes that I happen to have to hand, and one thing that I have found is, as you would expect, these are actually interchangeable and do fit together. Now I've gone ahead and I've dug out some of my other multimeters, and they come with their own test leads, and we've got a selection of those test leads here on the bench, and I thought it'd be useful just to check that these KAIWEETS probes do actually fit with my other test leads, because it's nice to be able to chop and change, especially things like these little mini grabbers, which I actually don't have with a 4mm socket on them. So I think we'll just try that one first, shall we? So yeah, they do go together, it goes together tightly. I can see that the way that the insulation is around the KAIWEETS probes, it does actually correctly terminate with the other leads of these other voltmeter cables. I'm guessing that this must be some kind of standard interconnect, but yeah, they go together very nicely. Should we just try some of the others? Yep, certainly they fit. So far I've only tried the KAIWEETS cable in this particular AVO voltmeter, but let's try it in some of the other equipment we've got on the bench. Now again, these should be a standard, so I would expect that they will fit anything. Certainly it fits a fluke. Fits this SAMO insulation resistance meter. Oh, but strangely enough, doesn't seem to fit this Fluke 25 very well. So yeah, so if you've got a Fluke 25 meter, don't buy this style of KAIWEETS. For some reason they don't actually fit very well. Not sure why. I've got a bunch of cables here from other manufacturers. Let's see if these will fit the Fluke 25. That one fits. That one fits a little bit tighter. That one fits. That one fits, and that one fits. So the others fit. Let's go back to the KAIWEETS cables. Yep, the KAIWEETS cables are just very tight. Now I suspect you could probably force them in, but yeah, you wouldn't want to do that. You might damage the test meter terminals in there. So for whatever reason, can't really explain why, but the KAIWEETS leads don't fit this Fluke 25 very well, although they don't seem to have any problems fitting the other meters I tested with them, so that's a bit of a strange one. Now unfortunately not very much information comes with our KAIWEETS probes. In fact it's limited to this little tiny booklets, but one of the more interesting parts of the specification deals with the electrical safety rating of the various parts. Now interestingly enough, I suppose it's obvious really that all these different devices, whether it's the probe tips or the cable itself or these mini grabbers or the crocodile clip, they've all got a different electrical safety rating. For example, our mini grabbers are rated to Cat1 300 volts at 3 amps. So that's these. So yeah, these are only category 1. So you'd only want to use these on relatively low voltage stuff, and stuff which is fuse protected where not a lot of energy can flow in the circuit, because the idea is if something goes wrong with the test equipment or the probe, you don't want the circuit to deliver enough energy that could be potentially dangerous. It could make the probe explode or maybe give you a fatal electric shock. So these are limited to fairly low voltage use at Cat 1. It says that the Alligator clips, let me just find them. So here's one of the Alligator clips. So this is limited to Cat 2. So this is 300 volts up to 15 amps. And the test probes themselves, they're actually limited to Cat 2 at 1000 volts, 10 amps. Now I would actually be expecting to see a higher category for a probe like this. I would expect it to be at least Cat 3 or Cat 4. I've just noticed though that this cap on the end of it actually does say Cat 3 1000 volts, so it could be that the probe without this protective cap, if it's exposed like this, maybe it's only category 2. In fact that's what it is. So the bare probe like this is only category 2, whereas if you actually put this shroud over it, it extends it to category 3. Certainly here's just an example of another probe that I've got, and this one is, for example, this is category 3 at 30 amps, so it's a considerably higher specification than what this KAIWEETS probe is. Now I'm certainly no expert on the safety and CAT ratings of electrical test equipment, and the CAT rating system isn't just as simple as giving you a maximum voltage that you can work with. The CAT rating is actually to do with the combination of voltage, but it's actually got much more to do with the potential energy that the circuit under test can deliver. So for example, if you were working on something like a small battery radio, the potential energy that can be supplied from a small battery radio from just a few D cells, the actual energy is very low and the voltage is also low. Whereas for example, if you were to make some measurements on the lighting circuit at your house, well, the lighting circuit would be at higher voltage and can also deliver higher current. And then going one step further, if you go to the consumer unit in your house, maybe that's fed from 100 amps fuse and maybe at 230 volts. So again, that would be a higher safety category rating. And certainly in the UK, our consumer units are actually fed from a fuse which is supplied by the DNO, which is the company or the organisation responsible for delivering the power. Now the DNO will actually provide you with a main fuse, so your consumer unit is maybe fed with 100 amps, but on the other side of the fuse, the power supply and the cabling, which is owned by the power company, that could actually deliver many thousands of amps, because effectively it isn't really fused until it gets back to the electrical substation. So certainly you wouldn't want to work on something like that with these test meter probes, because they don't have a sufficiently high category rating. So for most hobbyists, I don't think the CAT rating is really that important, because we're going to be working on relatively low power equipment. If you're working on high power equipment, you wouldn't be using these type of test leads. You would be using something which is more professional and probably is inspected and tested on a more regular basis. But one thing that has taken my interest about these is, although they have said the category and rating for all these pieces of various equipment here, one thing that I would have liked to have seen was who did the testing. Now, I'm not saying that I don't trust this KAIWEETS brand. As far as I know, they're a very well respected manufacturer of test equipment. They make many thousands of multimeters and test leads, but they actually don't say in this manual who does their testing, who the underwriters are. But certainly if you buy some test leads for somebody like Fluke, it will actually say in the specification who they were tested by. It will give you the UL listing, the underwriter listing, and really that's just confidence factor for you know that the equipment that you're using is going to be safe and it isn't going to blow up in your hand.
Want to test the meters so they don't blow up in your hand. So this meter is rated to 750 volts. So you can see that it actually measures 750 volts just fine. Now the important part of this is what happens if you put the meter in a function other than volts. So in this case I've selected an ohm circuit. So that's what happens if the meter is not designed correctly.
Now, I certainly can't do any meaningful safety testing on these leads or make any recommendations, but for my own interest, I think I would just like to make sure that they're at least insulated enough to actually be used with this high voltage insulation meter, which works up to 1000 volts. And I've actually got absolutely no doubt that they will be, because it doesn't actually take very much plastic material to insulate you from 1000 volts. And the quality of these test leads is actually very good. My only complaint with them is they're perhaps just a little bit stiff. Maybe they will loosen up a little bit with time. But yeah, the leads themselves feel like good silicone rubber and are quality. So let's just plug these in. So we'll turn our meter on to 1000 volts and we'll turn it on. So we've now got 1000 volts in our test leads here, and I can't feel a thing. And of course I didn't expect to. One important thing about things like meter probes is they should be touch proof, which certainly they seem to be to 1000 volts. And I know you wanted me to do it. And again, got 1000 volts on here. And can't feel anything. So certainly they're insulated to 1000 volts. That's no surprise. So our test lead set did come with some mini grabbers, here they are, and it also came with a couple of crocodile clips, and I think they've actually got the rating written on them, so I think these are a lower voltage. So it actually gives you a maximum working voltage for these. This says Cat1 300 volts. So certainly you wouldn't want to use these. I wouldn't want to use them in a very high voltage circuit. I probably wouldn't want to use them at mains voltages. And again, these are also rated at just 300 volts, and I'm guessing one of the reasons that they're rated at that much lower voltage is because they've just got more exposed metal on them, which is a good thing when you're trying to clip them onto stuff. But yeah, they've got more metal, whereas I have got some higher voltage leads here, which they've just got a thicker shrouding around them. So these are a category 3 lead, and you can just see they've got lots more insulation. So if I was to work on mains equipment, I'd probably want to use something like this rather than these smaller mini grabbers. As much as anything, because if you had to install these on a high voltage circuit, you're actually having to get very close to it, putting your fingers in. Whereas if you're using something like this, okay, it's a bit bigger and it's a bit more unwieldy, but I'm actually kept well away from the wire that I'm trying to grip onto. Whereas this type of small crocodile clip, yeah, I wouldn't want to get very close to live wires with it. Certainly wouldn't have any issues clipping this onto a grounded chassis, that would be fine. But I think I would think twice before clipping this onto a live terminal. I'd probably want to de-energise the circuit first. I guess we should also explore the connectors at the other end of the test lead. So again, we're set to 1000 volts, and I'm giving it my finger test here. And I'm going to grab the wire and run my hand against it, and I'm going to give it a good squeeze. And I think if there's any kind of break or an exposed section of cable, I think 1000 volts will point it out to me. No, so certainly absolutely fine at 1000 volts. Now of course the same might not be true at 10,000 volts, so let's find out. Remember, these cables are not rated for 10,000 volts. Wind up the power to 10,000, in fact let's wind it up to 12,000. So certainly the handle here is very well insulated. If this was actually leaking at high voltage, you would hear a hiss. I could hear the corona and I'm not hearing anything. So it is breaking down there, but it's actually not the actual test lead that's breaking down, it's just actually making a jump over to the earth strap that I'm using. Well, that was fun, if not entirely pointless. I guess before we finish today we should really just check the resistance of our leads, so let's go ahead and do that. Let's test the resistance of the leads first, see if there's any difference. So I'm going to use this DR meter because I think it's about the lowest ohm reading meter I've got. So let's try the first lead. And that's coming up as 0.023. Let's try the red lead. That one's coming up as 0.032. And let's test the length of the leads all the way up to the tips. And that measures 0.071. And just as a comparison, let me try my everyday test leads. Okay, so my everyday test leads are just a little bit lower in resistance. They're coming up 0.061. So it does appear that my existing test leads are very slightly better at 0.01 of an ohm difference. Now for those of you that like it rough, you'll be glad to know that these test leads have been tested to 900 newtons, which I believe is just under a kilogram in old money. Well, in summary, what do I think of our KAIWEETS KET01 test lead set? Now when I went shopping for probes the other day, there was a couple of things that I was really looking for. Now the first thing is, because I actually own several multimeters, I didn't particularly want to spend a huge amount of money buying some test leads for them. And when you do go shopping for test meter probes, you will find that there's a huge amount of variation in terms of cost and in fact also specification. Now at the top end of the range you have lead sets made by companies such as Pomona. Now of course those Pomona test leads, they will have nice features on them, like they will be gold plated, the tips on them, so they'll have better conductivity, they don't corrode or oxidise, the leads themselves will be more flexible and the general construction will just be higher quality. And at the absolute opposite end of the scale you have these KAIWEETS probes, which are designed really to be a very low cost entry style probe and to offer you quite a range of features. So we have a variety of probe tips here, we've got some crocodile clips which slip on, and we've got the mini grabbers, and they deliver all that for just over £13.99, so that's a plus point for me. Now of course if you do want to go ahead and spend £140 plus on a set of test leads, there's actually nothing wrong with that. Personally, I don't think my measurement confidence would actually be increased by spending more money on a probe set. Of course your usage case could be quite different. You might need to measure very low resistances or measure high currents or in fact high voltages. Now regards the electrical safety of these probes, it does actually say that they have been tested and it gives you a range of voltages and currents that these can safely work at. And again, as a hobbyist user, I'm not likely to exceed these ranges or ratings. Both of the crocodile clips here have good firm springs on them, and they seem to have quite sharp jaws on them, so they do make good contact with anything that I've clipped them onto, so certainly that's an advantage. And as I've mentioned several times, I really do like the fact that the design of the probe is modular. And again, the modular probe could be a compromise in some situations because you are adding another set of contacts here. So again, if you want to measure the most ultra low resistances, you probably don't want probes which you can split into parts like this, because you're just adding another set of contacts. Now, I've actually been using these test leads on the bench for about the last month, and I've got to say that my opinion of them really hasn't changed very much since I first unwrapped them. I still think that the pointy-ended probe here does just feel a little bit cheap in the hand. I do prefer test meter probes which have just got a softer feel to them, the ones that have got like a rubber over moulding, but you're probably going to pay more for that. They just feel a little bit plasticky. The finger guard on the front of them is very, very positive. I actually don't mind these shrouds on them. They seem to clip on well, and I haven't lost them yet, which is something. I still don't like the fact that the actual, where they plug together here, this connector, it does actually have a little finger guard on here, and I'm guessing that finger guard does fulfill a function. But again, I just find that when I hold it in my hand here, it does just rub on the back of my hand, and my opinion about that hasn't really changed. I just find it a little bit annoying. But I don't actually have to hold these test leads in my hand all day. There will be engineers out there who work on a test bench where you will be using them all day, and that, again, that could be a consideration for you. Now, the leads themselves are actually made from a relatively thick rubber material, and I do believe it is a silicone rubber, but I would say that certainly they're not quite as flexible as some silicone leads that I've got. But I do want to make the point that although they do feel very slightly stiffer, that no way detracts from the usability of them. They're actually fine to use, no problem whatsoever. So the connectors on the test leads do feel like reasonable quality, and with the exception of the Fluke 25, they did actually fit all the meters that I tried them in very well. And at both ends of the probe they are actually fully shrouded, and even the tips of them have a piece of plastic on them, so they are entirely touch-proof. Now, on a variety of components, including through-hole components and in fact point-to-point wired chassis like I used to work on, these actual mini grabber probes work really well. I was a little bit disappointed to find that they were just slightly too large to fit on the legs of dual inline packages, so that was a little bit of a shame. But again, if they had been much smaller so that they would fit onto dual inline packages, they probably wouldn't have fitted some of the larger things that I work on. So again, these are always a compromise, and perhaps you need a few different sizes of these. So having used this probe set on the bench for the last few weeks, I am actually struggling to think too much of a downside to using these. It could just be that I'm not a very sophisticated user. Now, if you do choose to shop for these probes on Amazon, you'll actually see that these have got the highest customer rating by a country mile. And whilst you can't always trust these Amazon customer ratings, in this case I would actually say that it's true. These probes do offer absolutely outstanding value for the money. So giving consideration to the very low price point and the fact that they are supplied with a good all-round set of clips and connectors, I certainly don't have any hesitation in recommending these. But I think for today that'll do. So until next time, as always, thanks very much for watching, and I hope to see you again very soon. But bye bye for now.